right, so good morning. Very important topic today is a small concept I want to discuss with you is on capacitance. If you look at a capacitor, and if I were to ask you a question, what is the initial current in the circuit when you connect a capacitor with a battery or a cell, right? The initial current. Now, there could be many options, right? So we're talking about initial current. That's a key word here that you need to focus on. Initially, when the current flows in the circuit, that current is purely determined by the resistance of the circuit. The capacitor has no role at all to play. And that's a catch. Assume a situation that the capacitor is obviously not charged from t is equal to 0. I hope this makes sense to you. So the initial current which passes through the circuit when you connect the capacitor to a source of EMF is equal to the EMF of the cell divided by the resistance. Now, where does this resistance come from if the circuit is purely capacitive? The wires in the circuit do have some resistance. So that initial current that starts flowing is only because of the resistance. As the charge starts building on the capacitor, starts traveling from wires towards the capacitor, starts building there, that charge gradually starts repelling back the charge in the wires. So the charge is getting built now. We are no longer at t is equal to 0. The time is increasing. And now the charging of the capacitor is happening. But as the charge on the capacitor increases, it gets the capability to push back on the electrons that come from the wires, which means the rate at which the charge builds up with respect to time, which is the current itself, the rate is not linear like it is in a resistive circuit. So therefore, after a certain while, the potential difference between the plates of the capacitor becomes equal to the EMF of the cell. Now the capacitor has reached the maximum charge it can have in such a way that no longer further charges can flow in the wire. If you were to ask, now there is no flow of charge, what happens to the overall charge which gets deposited on the capacitor? At this point of time, the charge on the capacitor is given by the product of EMF of the cell and the capacitance of the capacitor. Remember, this process is very gradual. You must read how the current equation or the charge equation of a capacitor as it is connected to a DC source, and the charge starts building on the capacitor. So you need to study two equations. One is charging of the capacitor. The second you need to study is the current buildup in a capacitive circuit. And similarly, you can study about the discharge of the capacitor, right? It takes some time because of the charge which already exists and now you want to discharge. Develop a line of thinking. Whenever you see a question on capacitor, there's a way you need to think about it. The conditions are initial conditions, are they final conditions when the maximum charge is built up, or are these interim conditions? And the key to understanding this comes from the equation. Understand the equation, derive the equation, get the significance right in your head. T is equal to 0, T is equal to capital T, some time instant, and T is equal to infinity. A lot of time has elapsed and the maximum charge is getting built up. Thank you very much for your time. Do watch my videos, subscribe to them. I see a lot of students from UAE, United States, Portugal, now Australia, and Philippines watching my channel, and of course, India. My request to all of you is to please subscribe so that I can also feel encouraged a bit when I make these videos. I hope these are helping you. Do subscribe so that you don't miss out on an important concept just like today. Thank you very much.